Hello and welcome to another Chipro Design Manager video. In this video, we'll be talking about the analog design flow in the Design Manager. We'll be explaining everything. We'll be building an inverter with its test bench together, and we'll be covering the simulation, the schematic, the symbols, the DRC and the LVS over the layout. We'll go through everything in detail. So if you haven't seen the previous videos, I recommend that you go watch them first. And if you're ready to go into this video, let's go ahead and dive into it. So we've shown this before. We'll start by creating our inverter project, and we'll attach it to the GF180D variant. Then we'll create the library and the cell under that. So we have our inverter library and we have our inverter cell here. Great. Let's now create our schematic. So we can create a schematic here. So we can go ahead and select it and open it in XSCAM. So this will open XSCAM here. We can start designing our inverter. You can start by pressing I. Once you press I, this window will pop up, and you can go here to the 5 volts and you can search for inverter to add our inverter. So we will select the inverter symbol here and we'll add it, press OK, and there is our symbol. So we now want to add the pins. We also press I again, then we go to the basic devices here and we search for an input pin. So this is our input pin. We'll select it and we'll add it here. We can also get our output pin, so we search for O pin and we select this pin and we add it here, but we want to rotate it, so we press R twice and this will rotate the pin. You add it next to this one, and now we want to wire them. So you go hover over here and you press W and the wire extends with you, and then you press W again and this adds it. You can then press escape to get out of this pin. So now we've connected it. We do the same here and we connect them. Then we can change the name of the pins. You can do that by either double clicking here and changing the name here to in and press OK, or you can go here and you can press Q and you go ahead and write out here. So this is the output pin. We also need to add 2 pins for the VDD and the ground, but this will be of type IO pins. So you select this one and you press OK, you add it here. You can also copy this one by Control C and moving down and you add it here. So these are our VDD and ground pins. You go here, you press Q, you write VDD as the name of the pin. You also rename this to ground and we wire those. So we press W here again, and we also connect the ground here, W here again. This will also be connected to VDD, so we can connect it like that. Press W and move up again. Press W, now they are connected. We also connect this to the ground, so W here, move up again, and press W. So this is our inverter schematic. We can save that, and we can save the file. So let's first go ahead and create our symbol. You do that by going to symbol here, and you make symbol from schematic, and you press that, and you press OK. If you go back to the design manager, you will see that our symbol is generated. We can also open it in XSCAM, and this is our generated symbol. We can also generate our our SPICE netlist and our LVS. To generate the SPICE netlist, you go ahead to the options and you choose the SPICE netlist option. Then you press on netlist. This generates the netlist. You can also check that by going to the design manager. We have our SPICE netlist here. You can open it in VS Code. So this is our SPICE netlist. You can go ahead and review it. So let's close that and let's go ahead and generate our CDL netlist or our LVS view. So this is a bit tricky. You need to change some configurations. You first need to go to the simulation tab and you uncheck this option. You also go ahead and check our LVS netlist top level option. You also have to go here and set the top level netlist name, and you must take care of this, that you must name it the same name as the cell. So we've named our cell the inverter cell, and you add .cdl to it, and this will create our LVS view. If you don't name it exactly the top cell name or the cell name which you created this view under, .cdl, it will not be detected as the LVS view here. So we've added it here. Once we press on netlist, it will be generated. We can go back to the design manager and we can check our CDL or LBS view here. So we will open this in VS Code, and this is our netlist. So that's it for the inverter. Before building the layout, let's go ahead and create a test bench to simulate this. So let's create another cell. Let's call it our inverter test bench, and let's add it here. We can go ahead and create our schematic, and we can also open this next scale. So let's close this one, and let's start designing this here. Okay, so we can start here by pressing I. You can go here to the top level project. I'll show you now. Let's extend this. You can go here to the project, go to the inverter library, go to the inverter itself, which we just created, the schematic, and you choose the symbol. So this is a symbol we created earlier, and you can add it here. So it says missing symbol architecture. So let's go ahead and check why that. So we should press Q over here. And you can see that it imports it from inverter library, inverter schematic architecture. So we added an incorrect symbol. So let's go ahead and delete that. You press I here, you go home, and you go ahead and check the project. You go to the inverter library, the inverter itself, and you choose the schematic. Then you add the inverter symbol, and this added correctly. I selected the architecture the previous time by mistake. But anyway, we now have our inverter symbol. We can go ahead and start getting our connections. First of all, we need to add an input and output labels. We also need to connect the ground. So let's go ahead and wire up our connections. We can start by adding, let's go ahead, you press home, this takes you back here. We can start by adding our ground. So this is also one of the basic devices. You choose ground here and you press OK. You add the ground. You can add it here. We also need an input source. So we go here and we search for a vSource. You can find a vSource here. You press OK, and you can add that here. If you want to move anything in the schematic, you can like press it, press M, then move it, then press it again, it moves. We can also move this source down here just to make our wiring a bit easier. Then we can press Q to switch the values. We want this to be a 5-volt source. So we press OK, and this changes it to 5. We'll keep it named as V1, doesn't matter. Then we can just connect our connections. We add our wiring here. This is our VDD. Then we connect this to our ground. We also connect this ground here. Then we can add a label. To add a label for the output pin for our simulation, you press L. Then you can rotate it twice by pressing R, and you can add it here. So this will be our output. We can rename this and rename it as out, and we press OK. Then we can wire it like that, and then you can see that it's wired. We also need to add our input source. So this will be a pulse. So you can go ahead and press I. We also need to add another V source. You get this one. No, you go back to the basic devices, the V source, and you press OK. You add this one here and you wire it up. So you add this here. Then we also need another ground, so we can just go ahead and copy that. We add it here and we wire this one to the ground. We want to change the signal of this one, so you double click on this one and you choose it as a pulse. So you come here to the value and you add 2 double quotes, and inside that let's add a pulse of 5. Then let's make those as zeros. Then we'll have 100 nanosecond here, then 200 nanosecond for the whole period. Then we close the brackets, and that's it for our sinusoidal input or our square input. We add another label here. No, not this one. Oh, my bad. We'll need to add this one again. So we add this one here, and we name this as V2, and the value, we put the pulse again, just like we added previously. So this will be 5, then 1, 2, 3, our 4 zeros, then our 100 nanosecond, then our 200 nanosecond period. Then we press OK. Then we go here, then we add a label, we rotate it, we add it here, then we rename it to input. We'll use that to visualize our input in the plot. So we press OK. Okay, so now we're ready to add our models and our control block. So we need to add model imports here from the technology. We will add this by default or automatically in the future, but for now you will have to write it yourself. So how you do that is you also press I, you go to the basic devices and you search for a code shown block. You add this symbol and you add this here. Then you open this one. So let's call this our models. So this is our models, and we go to the value and let's add our value here. So let's switch this to true, as this will only be applicable to the top level. We will go here to the value and we'll add this here, also add this. Then we will write our include code block. So how you do that is you write dot include and you use and you add the path to the ngSpice file in the technology itself. So how you do that, you can use our predefined variables. So you write $sign and you define our PDK path. This is the variable we defined before. This is a combination of the PDK root plus the PDK variable. So you use the PDK path and you go to libs.tech, then you go to ngSpice, and then you go to the design.ngSpice file. Another simpler way to do that, I'll show that here in the library include. So you include the library, you can use directly we have a defined variable called 180 MCU underscore models variable, and from that, this takes you directly to the ngSpice directory, and you can go ahead and add your SM141064.ngSpice. Then we'll add the typical. So I believe this is correct. And to evaluate these variables, you need to make sure that you add the format variable here. So you add format equal tickle evaluate of at value. And then you can save this one. So this is our models include block. Okay, this is great so far. Let's go ahead then and add our other control block input. So you also go ahead and from the basic devices, you choose a code shown block and you add another one. You go here and you press Q to open this window as shown before. You only need to edit the value here. So let's add the value and we can add our control block here. We want a transient analysis. Let's make it 0.1 nano and 600 nano. We also want to plot our input pin to our versus our output pin. Let's add a -6 here to visualize it easier. So I believe this is now correct. You can press OK here. And I think now we're ready to simulate. So first of all, you should go to the options, choose the Spice Netlist option, make sure it's selected. Then you generate our netlist. Now our netlist is generated. You can go here, you can open it, and you can review its contents. As you can see here, this will include our includes and everything we added in the blocks in the XSChem file. So you can close this for now and you can run a simulation. We have an error here. So it says that unknown subcircuit X1 in net1 and output and the redundant control card. So yeah, first of all, we missed something here. We need to add our end for the control block. We can save that and we can regenerate our netlist, and this fixes the issue. As you can see, our inverter is working correctly. This is our input and this is our output. As it's low here, it's high here, and then as it's high here, it's low here. So our inverter is working perfectly. So the last thing to do here is to go ahead and create our layout. So let's save that before we close. No, cancel that. You can save. Yes, we want to save this file. You can go ahead and close that. Then back in our design manager, we've seen everything up till now, how to create the schematic, the LVS, the net lists, and plot the simulations, and everything is ready for now. The only thing that's remaining is to add our layout. So you can go ahead and create a layout view here. So let's create our layout view and open it in KLayout. So now we can start designing our inverter. You can see that everything is loaded related to the technology correctly. You can choose the instance. You can go here. You can choose anything you want. Let's choose the P cells. We'll also you can see that all the options are available here, and you can modify it however you want. Let's take a look at that. So you can go to the P cell. You can switch this to 3.3 volts, and you'll see the change. You can also play around with the properties here a bit, so you can do that. You can also modify any of the properties here. They're all working correctly. You can change the number of fingers to one or to two. It doesn't matter. Like basically, you can play around with the options as much as you want. You can put this at the top, and you'll see that it moved. So everything is working correctly. The video has been long so far, so I plan to just copy the layout. I've already built it previously, so let's go ahead and just delete this layout. So let's close it first. Yeah, we do not want to save anything here. Let's just delete this one. So I do want to delete this layout. I can go here, analog library, and I can go to the inverter. I have built this layout before, so let's copy it. You right click on it, you press copy, and you go back here, choose the same library, the same inverter, and you paste it here, and you just paste. So it says that a cell with this name already exists. I believe I pasted the cell. I should have pasted the view itself. So to paste the view, you press the paste button here, and you paste this. So now we have the layout pasted here, and we can open it. Let's go ahead and see it. This will open the design and the layout here. As you can see, this is our inverter. So let's check how we can run DRC and LVS. So to run DRC, you can choose this option under the GF180 MCU PDK, and you can change the options however you want and play around with it. So we'll leave them as the default for now, and let's run DRC for this layout. So we will run KLayout DRC. This runs the DRC for this inverter, and as you can see, there are no violations whatsoever. Everything seems to work correctly, perfectly. So let's close that. Let's go ahead and run our LVS. We can play around with the files here. We can set the netlist. So you can browse here, and you should go to the inverter CDL. You should check the CDL that we created. So if you do not know how to select that, you can go back to the designs area. So under the user area designs, you can go to the inverter cell you created, and under the schematic, you can see the CDL you created. You need to check that the DRC variant is D correctly, and everything is set correctly. You can play around with this if you want. You can press OK. Then you go ahead and run KLayout LVS. So this is the KLayout LVS results. Everything seems to be working correctly. Everything is cross-referenced. Everything is matching. There is no errors whatsoever. Everything is clean and seems to be working perfectly. So this was just like a very quick walkthrough for the analog design flow in the design manager, how you can run everything, use the PDKs, perform simulations, run DRC and LVS. Thanks. This has been everything for this video. If you have any questions, please add them below. We will answer them. Please don't forget to like and subscribe. Thanks.